Hello, today we're going to be solving literal equations and formulas. So from the last lesson we had talked about just a generic equation getting a variable by itself. That's what we're going to start with here. We want to solve for the variable that's in the parentheses after the equation. So for this one we want to get y by itself. So for number one, what we're going to do is move the ax to the other side because that's being added or subtracted. So we have by equals, and this y right here, sorry, is not part of the problem. So it's c minus ax. Now our goal is to get y by itself. So right now the b is connected through multiplication. So in order to undo that, we're going to go ahead and divide both sides by b. So you can write this two different ways, c minus ax over b, or you can also do c over b minus ax over b. Either one of these is correct, and I'll accept both answers. For the next one, we want to get b by itself. So the b is inside the parentheses here. So I noticed we have that 1/2 out in front. Let's go ahead and get rid of it by multiplying both sides by 2. On the left-hand side, we get 2a. The 1/2 and the 2 undo each other, so you're left with h parentheses b plus c. So there's many different ways you can do this. If you're someone who wants to distribute the h, you can do that. I'm going to go ahead and divide by h on both sides. But again, if you distributed, you would get the same answer. So I'm dividing by h. You get 2a over h equals b plus c. Now again, our goal is to get b by itself. So we're going to subtract c from both sides. So b equals 2a over h minus c. Now, if you were someone who distributed, you might have your answer look like this, 2a minus ch over h. That's the same thing. So if you get something equivalent, but it looks different, that is totally fine. So now what we're going to do is we're going to take this idea of getting a variable by itself, and we're going to apply it in different situations. So this first one is someone who is making a rectangular frame. So we have this rectangle shape. We want to find the perimeter of the frame. So worst case situation, if you come up across a formula you don't know, Google it. We have those options available to us. For the perimeter though, we can actually figure that out. If we call this length and this width, the perimeter would be adding all those together. So there would be 2 L's being added to 2 W's in total. Now what we're going to do is we're going to take this formula and we're going to solve for something else. So we're going to take this equation and we're going to solve for the width of the frame. So we get P equals 2L plus 2W. W is the one we want to get rid of, or get by itself rather. So we need to move the 2L to the other side. And since it's separated with addition, we're going to go ahead and subtract that from both sides. We get P minus 2L equals 2W. Now the W is almost by itself. We're going to have to get rid of that 2. So in order to get rid of that 2, we're going to divide both sides by 2. And I'm going to start breaking up my fractions here. You can definitely leave it as P minus 2L over 2. I'm going to start breaking those up a little bit more. So it's going to, I'm going to write it as P over 2 minus, and when I do 2L over 2, the 2's are going to undo each other, and I just have an L there. So the width is taking the perimeter, dividing by 2, and subtracting the length. So the reason why we're doing this is because now we're going to apply it. So this next part, we're told the perimeter is 144 inches. That is the P in the formula. The length of the frame is 40 inches. That is the L in the formula. We want to determine the width of the frame. So we don't know what W is. That's what we're trying to find. And if we look at the equation just above, we actually have an equation that will tell us the width if we know the perimeter, which is 144, and the length, which is 40. So if we plug in the P and we plug in the L, now we can go ahead and take this and figure out what this equals. So this is going to be 72 minus 40. So the width is going to be 32 inches. So let's take a look at another context or another situation. So this one is a formula we may not be familiar with. We are given the simple interest formula. So sometimes if we're working on formulas that we don't recognize, you will be given those formulas. So I stands for your interest, P stands for your principal, R is your interest rate, and then T is your time. So we're given the formula and we're told what each of these parts stands for. Then we have Janet here. She's trying to calculate the time it takes to earn a certain amount of interest. So we want to figure out what equation she could use. So it's going to be involving the I equals PRT. And so she actually wants to know specifically how to calculate the time. So what we're going to do is that is going to be the variable that we are going to solve for. So right now, it's P times R times T all together. If we want to get rid of the P and the R, since they're being multiplied, we're going to divide both sides by P and R, the principal and the rate. So to solve for the time, what you can do is you can take the interest and divide by the principal times the rate. That's the equation she could use. For the next one, now we want to take this and we want to calculate the principal amount. Now the principal amount, if we go back to our variables up there, is the P part of this. So we're going to go back to our initial formula, I equals PRT. Now we're going to solve for the principal. So we want to get rid of the rate and the time. To undo the multiplication, we're going to go ahead and divide. So the principal equals the interest divided by the rate times the time. So we're going to look at just a couple more examples here because there's so many different situations that can pop up. We can't possibly do every situation, but we can at least do a bunch of different examples so that we feel comfortable in those new situations. So now we want to calculate the height of a triangle when given the area and the length of the base. So now for this one, I'm seeing this keyword being area. That's going to tell me the formula that I need. So A says write the formula for the area of the triangle. So our area is going to be 1/2 of the base times the height. We're going to use our formula and we're going to solve for the height. So we want to get that h by itself. So I'm going to go off to the side so I can show a little bit of work. So if I want to get h by itself, I'm going to get rid of that 1/2 first. I'm going to multiply by 2 on both sides. I get 2a equals b times h. And again, I want to get h by itself, so I'm going to get rid of that b by dividing both sides by it. So the height of the triangle is equal to twice the area divided by the base. So now part C here is asking us to take it and actually use it. So our area is 12 inches squared and our base is 9 inches. So we want to calculate the height when the area is 12 and the base is 9. So we're taking that formula and plugging in the A and the B. And so we can go ahead and calculate that. That's going to end up being 24 over 9. That does not divide nicely, so I'm just going to reduce this. So it's 8/3 inches, or you can write it as 2 2/3 inches. Let's look at another familiar now that we're not, or a formula that we're not familiar with. We have Rob being an electrical engineer. He's calculating the length of the wire. So here's our first variable. The L is the length. The resistance is the R. The resistivity is the P. And then we have one more here. The area of the wire is A. Okay, so we have all of these different things to calculate the electrical resistance. Now, these are things that we might not be familiar with. However, because of that, we are told the formula we're going to use right here. So we want to find an equation that Rob can use to solve for the length of the wire. So the first thing is to figure out which variable we want to solve for. The length is up here. That is your L. So we're going to take this formula and we're going to solve for L. So R equals the ohms times the L over the A. So what we're going to do is we're going to go ahead and get rid of that divided by A. We're going to get rid of it by doing the inverse operation and multiplying by A. We get AR equals the ohms times the L. Now what we're going to do is we're going to divide both sides by that P looking thing, the ohms. So looking at this, your L is going to equal A times R divided by the ohms. That would be your formula you can use to solve for the length of the wire. And our last one here, Teo is looking for a recipe for bread, and now we're looking at maybe a British recipe or something. Everything else is in Celsius, but our ovens are in Fahrenheit. So that is an issue. We're going to try to convert in between Celsius and Fahrenheit. So this is again maybe another formula that we're not as familiar with, so we are given it. We're going to use this to solve for F. So what I'm going to do is I'm going to get rid of that 5/9 out in front by multiplying by 9 over 5. That's going to undo the 5/9, so I get 9 over 5c equals F minus 32. Now to get F by itself, I'm going to go ahead and add 32 to the other side. So our temperature in Fahrenheit is going to be 9/5 of the temperature in Celsius plus 32. That's how we can convert if we're given something in Celsius to Fahrenheit. So looking at Teo's recipe, now he has the bread, it's 190 degrees Celsius. So this again is our C value. So in order to figure out our Fahrenheit, we are going to say the Fahrenheit should be 9/5 of the Celsius, which is 1 plus. So and calculate what that would equal. You could do that, or you can use a calculator, and we should get 374 degrees. So he should set it at 374 degrees Fahrenheit in order to have the same 190 degrees Celsius on his oven. So thank you very much for listening.